Okay, this is 9.2 Exponent Rules. So we're going to be looking at various operations on exponents this week. We're going to start with the product rule. And so the word product refers to the answer to a multiplication problem. Okay, so this is when we're multiplying exponents. So I want you to go ahead and pause the video and write this down. When multiplying exponents with the same base, you add the exponents, okay? So key things here. So it has to have the same base. And the key is that we're going to add when you're multiplying exponents. All right, so let's look at an example. Hopefully this will make more sense. This first one we have down here is 8 to the 5th times 8 to the 3rd. Okay, well, 8 to the 5th, we know from last lesson, is just 8 times 8 times 8 times 8 times 8, right? And then 8 to the 3rd is just 8 times 8 times 8. So what do we really have here? I have 8 to the 1, 2, 3, 4, 5, 6, 7, 8th power. So rather than writing these all out every single time, that's supposed to be an 8, there we go. Rather than writing that all out, what we can notice is I can get a shortcut. If I just add the exponents 5 and 3, I get 8. Okay, so that is why our rule is to add the exponents when you are multiplying. Okay, all right, what about this next one? We have 9 or y to the 9th power, and then this is y to the 1st power. We don't really write it there, but we know it's there, right? Because if I were to expand this out, I would write 9 y's for this, and then one extra y for this. So if I add these together, 9 plus 1, I'm left with y to the 10th. All right, and now we've got a to the 4th times a to the 3rd times a to the 10th. So you could take all the time to write out all those a's, or you can just recognize that we're just going to add up these exponents. So 4 plus 3 plus 10, I think that's 17. So this is going to be a to the 17th power. All right, then this last one here, the 2 and the 3, these don't have exponents. I mean, they have got exponent of 1, but we can just treat the numbers as normal. Let's go ahead and write that down here. We're going to treat the numbers as normal. Okay, so I can just do 2 times 3, that's 6. And then the x's have exponents, so we're going to use the exponent rule. So this is x to the 4th times x to the 5th. 4 plus 5 is 9, so this is 6x to the 9th power. Okay, not too bad. Let's move on to the power rule. All right, so let's go ahead and write down the power rule. When you take a power of a power, you multiply the exponents. Okay, so the power rule is to multiply the exponents. All right, so let's look at this first example. We have 7 to the 4th to the 3rd power. So we remember from last week, if we were to expand this out, this is really 7 to the 4th times 7 to the 4th times 7 to the 4th, right? 3 times. Okay, and we know from the product rule that really what I'm doing here is just adding up the exponents. So I have 4 plus 4 plus 4, which is 4, 8, 12. Okay, so we have 7 to the 12th. Well, what's the faster way to do this? To recognize that our exponents here, 4 times 3 would get us 12 a little bit quicker. Okay, how about the next one? X to the 5th squared. Again, this is x to the 5th times x to the 5th. All right, and we know from the product rule that this would just be 5 times 5, right? But the faster way to do this would be to recognize we can just multiply our exponents and get 10. So this is x to the 10th power. All right. All right, moving on here. Here we've got a couple terms in here. We've got the negative 10 and the x to the 6. So it's very important that we recognize we kind of have to distribute this. I have to do negative 10 to the 2nd power. All right, and I'm going to put this in parentheses. Make sure you do that. If you put this in the calculator and you don't put it in parentheses, it will not get you the right answer. All right, so I get negative 10 squared, because this is really Let me write this out. This is really negative 10 to the first power. We just don't write it there. So that's 2 times 1, and that's how we get the exponent of 2. All right. So that's the first distribution kind of. Then I go to the second. That's 2 times 6, which is 12. So I've got x to the 12th power. All right, moving on. Now I've got 3 things to distribute. I got to distribute the 2 to the 1/3, to the x, and to the y to the third. All right, so I'm going to start with 2 to the 1/3. So this is going to end up looking like this. Okay, then I have to do 2 times 1 because x is raised to the first power. So this is just x squared, right? And then the last one would be 2 times 3, which is 6. So it's y to the 6th power. All right, moving on. Last rule we have this week is the quotient rule. A quotient is the answer to a division problem. So this is when we're dividing exponents. All right, so let me pull this over here. Go ahead and write this down. When you divide exponents with the same base, you subtract the exponents. All right, so underline some keywords here. Quotient means divide, and when we divide, we need to subtract the exponents as long as we have the same base. Okay, so let's look at this first problem here. 2 to the 5th over 2 to the 3rd, right? This is a fraction, which is a division problem. So let's go ahead and write this out. What does 2 to the 5th really mean? That's just 2 times 2 times 2 times 2 times 2 in the numerator, and then in the denominator we have 2 to the 3rd. 2 to the 3rd is just 2 times 2 times 2. All right, and we know that anything over itself is equal to 1, so a 2 on the bottom and a 2 on the top would cancel each other out. This would also be true of these 2's and these 2's. So what am I left with? I got these 2 2's in the top, so this is 2 squared. All right, and so what's the faster way? If we recognize we can get the same answer if we do the exponents 5 minus 3, that's equal to 2. All right, so this next one here, I don't want to write out 11 2's. I don't want to write out 6 2's either. So what I'm going to do is just take the exponents, 11 minus 6, which is 5. So this problem is going to be 2 to the 5th power. All right, how about this next one? Negative 4. Oh, I didn't write this base thing here. So the base, if you want to write this down as the base, and then you can just subtract out the exponents. All right, moving on. The next one I have is negative 4th to the 7th power over negative 4th to the 4th power. So the base is negative 4, and then our rule is to subtract the exponents, which is 7 minus 4, which is 3. So now I'm left with the base, negative 4 to the 3rd power. All right, how about this next one? What's my base? My base is x. And so I'm going to be subtracting the exponents, which is 5 minus 3. It's equal to 2. So it's going to be my base x raised to the 2nd power. All right, just a couple more here. So I have 3 over 12, or sorry, 3y to the 11th over 12y to the 5th. So remember, we're going to treat our numbers as usual. So we can just reduce that down. That's just 3 over 4, or sorry, 3 over 12 reduces down to, if you're not good at reducing or you just want to check your answer, you can always use your calculator. Get that N over D key. There we go. Enter it in, check your answer. 3 over 12 is 1/4. All right, so like I said, we're going to treat the numbers as normal. And this is going to, and then we can use our quotient rule for the exponents. Our base is y, and our exponents are 11 minus 5, which is equal to 6. So I'm left with 1/4 times y to the 6th. Okay, another way you might see this answer is if we had 1 and 4, and then the y would be up here. Y to the 6 would be up here. It would be unnecessary to write this 1, so oftentimes you would just see this problem as y to the 6th over 4, like that. Okay, so these are the exact same thing. Okay? All right, this last problem for this page, we've got 6 x to the 9th times y to the 4th times z to the 5th over 2x to the 1st, y to the 2nd, z to the 4th. All right, so let's start with the numbers. What is 6 over 2? Let's use our calculator just because we want to be perfect. 6 over 2 reduces down to 3. Sure enough, that checks out. Okay, so 3 is my whole number. And then let's go ahead and address the variables with exponents. So for my, remember, we have to keep the bases the same. So I can only do these with the x's. So x, we have to the 9th power divided by x to the 1st power. So this is going to be 9 minus 1, which is 8. Okay, now I can do my y's. Okay, my base is y. I'm going to do 4 minus 2, which is 2. And then last I can do the z's. Base is z. 5 minus 4 is 1. We don't have to write that 1, so I'm just going to leave it like that. Okay, now we're just moving on to the back page here. We've got a little bit more to do with quotients here. So if I have a fraction raised to the 3rd power, we just have to make sure that we distribute these to both the numerator and denominator. So this is going to be 2 to the 3rd over 3 to the 3rd. Okay, so this is really 2 times 2 times 2 over 3 times 3 times 3, which is in the end, what, 2 times 2 is 4, 4 times 2 is 8, and then 3 to the 3rd is 27. Okay? All right, so same thing with exponents. It has to go to the numerator and to the denominator. So this is x to the 3rd over y to the 3rd. Okay? And it goes to everything. So just like before, if I have a couple different numbers or letters in there, it's got to go to everything. So this is going to be 2 to the 3rd. And we do the second distribution to the numerator, x to the 3rd, over 2 times 3, which would be 6. So this is y to the 6th power. Okay, hopefully that made sense. All right, so if you are struggling with this, we can use GEMDAS to help us out with this, right? We've used GEMDAS in the past. Remember that M and D are kind of, multiplication and division are kind of like equals, and so are addition and subtraction. So if you're presented with those, you just solve left to right. But if we use GEMDAS, it kind of helps us figure out what the rule is. So let's look at this first problem, 5y to the 3rd times 6y to the 7th. Well, we know we can just treat the numbers as normal, and that's just 5 times 6, which is 30. All right, we know that this dot means we're going to multiply. And so if we look at this, multiply is right above the A. So if we circle that together, we know that the rule for multiplication is to add the exponents. So this is going to be y to the 3 plus 7, which is 10. So this is 30y to the 10th power. All right, how about this next one? We've got a power to a power, so that would be exponents, and exponents is right above the m. So the exponent rule is to multiply, okay? And remember, this has to kind of go to each one of these. This is 4 times 1, because the invisible exponent above the 4 is 1, so this is 4 to the 4th power. Then we go 4 times 5, so x to the 20th power. And we're going to erase this, 4 times 3, which is 12, so this is y to the 12th power. All right, And last one here, we have division, right? And division is right above the S. So the rule for division is to subtract. All right. Remember, we can keep the numbers as usual. 5/7, maybe you're not sure. You want to just check that one out. Does that reduce? Sure enough, it does not. It's just going to remain 5/7. Okay. And then we've got the same base, right, with my a's and my b's, so I can divide or use the rule to subtract the exponent. So my base a, I'm going to do 8 minus 5, which is 3. It's going to be a to the third power. And then my base b, I'm going to do 5 minus 3, which is 2. All right. So this, and I just want to show you, this is also the same thing as 5 being in the numerator with a to the third, b to the second, all over 7. These are, again, these are the same thing. Okay, they're equal. All right, last problem for the day. This one says bring the pane. This looks like it's going to combine all 3 rules. So let's give it a shot. How do we start this thing? Well, we've got GEMDAS written off to the side here, so maybe this will help us out. So we'll start with G. G is grouping symbols, right? All right, and we do have grouping symbols, but we don't have to do anything inside of them. So next I can move on to exponents. Can't spell. There we go, exponents. So I need to do that first. And what is my rule with exponents? Well, that is to multiply the exponent. So I'm going to start by distributing out this 3. This is going to be 2 to the third power. And then a, 3 times 3 is 9, a to the ninth power. My a's and 9's look pretty similar. There we go. And then b to the 3 times 4, that's 12. All right, so I've done that. Now I've got, I'm just going to raise up this part here. I'm going to do times 4a b to the 5th. Okay, so I can go ahead and multiply next, and multiply, here, let me change my marker here. Multiply is on top of the a, so I know if I'm going to multiply exponents, I want to add. Okay, I'm going to add the exponents. So on the numerator, I'm going to be left with, well, let's see. First of all, I should recognize that I have some numbers here. So 2 to the third is just 2 times 2 times 2, which is 8. I'm going to change that to 8. I'm going to treat these numbers as normal, like we said we were going to do. 8 to the fourth, 8 times 4 is 32. Okay, and now I've got the base of a, which is 9 plus 1, right? This invisible exponent of 1. 9 plus 1 is 10, so I'm left with a to the 10th power times b to the 12th times b to the 5th. So I'm going to do my base b. 12 plus 5 is 17. So that's my numerator. And then I can, so I'm going to put this right down here. 32 a to the 10th over b to the 17th, all over, I'm just going to slide this over, 64 a to the 5th times b to the 3rd. All right, 32 and 64, I can treat my numbers as normal. 32 is half of 64, but if you didn't know that, that's okay. You can go ahead, pull your calculator up, hit the fraction button. 32 over 64. That reduces down to 1/2. Okay, so I'm going to drop that into my answer here. This is 1/2. And now I have division. Change my marker one more time to green. Division, I'm going to subtract the exponents, okay? So my base A is going to be 10 minus 5, which is 5. And then for my base B, it's going to be 17 minus 3, which is 14. All right, so there you go. That wasn't too bad, was it? That's all I got for you guys. If you need more help with this, if this is not making sense, make sure you come see me, have your advisor give me a call. I can come down to your room or come see me on the Google Meet. All right, good luck.